Hi friends, you are welcome back to another interesting question. We are asked to calculate the areas of these two congruent circles. This quadrilateral is a square. The length of its sides are a each. We are given the length of this line segment to be 8 meters. That of this is 2 meters. Here, this angle. So how can we solve this? How can we calculate the area of these circles? The two circles in question, we are told they are congruent, so they have equal radii r. Formula for calculating the area of a circle is pi r squared. So their areas are pi r squared each. Therefore, total area is pi r squared plus pi r squared, which is 2 pi r squared. We need the value of r. Come here, this line segment, assume its length to be x and this y. This angle, assume its size to be h. Back to the square, we see this line connects two opposite vertices of it. That makes it a diagonal, and we know a diagonal of a square makes an angle 45 degrees with each side. Now come here, this angle and this are formed by two straight lines intersecting. That makes them vertically opposite angles, and we know vertically opposite angles are equal. So since this is h, this must also be h. Look at this triangle now. We see it has an angle h and an angle 45 degrees. Same as for this triangle. It has an angle h and an angle 45 degrees. That makes the two triangles similar triangles. Taking the ratio of their sides, this side x facing angle 45 degrees divided by this side also facing angle 45 degrees, let its length be t, must be equal to this 2 meters divided by this, which also equals to this y divided by this side, say n. So x over t equal to 2 over z, which equal to y over n. From here, x over t equal to 2 over z. Cross multiply, x times z equal to t times 2. So xz equal to 2t. Multiply through by 1 over 2. So t equal to 1 over 2xz. That is, the length of this side is 1 over 2xz. Come to this part, 2 over z equal to y over n. If you cross multiply and make n the subject, n equal to 1 over 2. Substitute it here. Now come here, from this point C, draw a perpendicular to this side AB. We look at this triangle. It is a right angle triangle and one of its angles are 45 degrees. Therefore, this must also be 45 degrees, and that makes the triangle an isosceles triangle. We know the sides facing the based angles are equal, which are this and this. We let their length be v. Since the triangle is right, we use the Pythagorean theorem on it. This is the hypotenuse. So by Pythagoras, 8 squared equal to v squared plus v squared. V squared plus v squared is 2v squared. If we take the square root of both sides of the equation, here square cancels square root, while here square root of 2v squared is v root 2. Multiply both sides by 1 over 2 root 2. Here v root 2 times 1 over 2 root 2 is v times 1 over 2 times 2, which is v, while here h times 1 over 2 root 2 is 4 root 2. So v equal to 4 root 2. That is, the length of these sides are 4 root 2 each. But this line AB, its length is a, and we have this side of it to be 4 root 2. Therefore, this must be a minus 4 root 2. Now look at this triangle. It is also a right angle triangle. We can use a Pythagorean theorem on it. This is the hypotenuse, say b. So by Pythagoras, b squared equal to 4 root 2 all squared plus a minus 4 root 2 all squared. 4 root 2 all squared is 32. So b squared equal to 32 plus a minus 4 root 2 all squared. Now come here, draw a straight line that will connect point A and E. We see this angle and this are both 45 degrees in size, and they both are subtended by this same line AE. This is a property of a chord in a circle. So if we draw out its circle, it will pass through the points. Now look at this angle 45 degrees and this. Both are subtended by the same arc. That makes them congruent. So since this is 45 degrees, this must also be 45 degrees. Same is here and here. They both are subtended by this. So this is also going to be H. We look at this triangle. Two of its angles have their sides to be 45 degrees each. That makes them congruent, and hence the triangle is an isosceles triangle. Therefore, this side and this are equal. So since this is 1 over 2yz, this must also be 1 over 2yz. We look at this triangle. It has an angle H and an angle 45 degrees. Same is for this triangle. It also has an angle H and an angle 45 degrees. That makes them similar. If we take the ratio of their sides, this side facing angle 45 degrees divided by this side must be equal to this divided by this, which equal to this divided by this. So b over x equal to 8 over 2, which equal to a over y. Here, a over 2 is 4. Taking this part only, b over x equal to 4. Make b the subject, b equal to 4x. Replace this with 4x, and here substitute it. Back to this part, make a the subject, a equal to 4y. That is, these are 4y. Here too, substitute a equal to 4y. This 4x all squared is 16x squared. From 4y minus 4 root 2, we can factor out 4. So it is 4 into y minus root 2. 4 squared is 16. From 32 plus 16, we can factor out 16. So it is 16 into bracket 2 plus y minus root 2 all squared. This 16, eliminate this 16. Keep this aside. Here, we know this angle is an angle of a square. Hence, it is a right angle. If we look at this triangle, it is a right angle triangle. We use a Pythagorean theorem on it. This is the hypotenuse. Therefore, 8 plus 1 over 2xc plus y all squared equal to 4y all squared plus 4y all squared. These can be written as 2 times 4y all squared. We take the square root of both sides of the equation. Here, square cancels square root. So 8 plus 1 over 2xc plus y equal to 4 root 2y. Keep this equation aside. Come here. Assume the size of this angle to be s. This whole angle ABG is an angle of a square. Therefore, it is right. So the sum of this h and this 45 degrees and this s is 90 degrees. Therefore, we can say h plus s equal to 90 degrees minus 45 degrees, which is 45 degrees. Now from this point, draw a line at an angle h to this side AG, and from this point, another line at an angle 45 degrees to this AG until they intersect. Call this point P. Look at this triangle. It has an angle h and an angle 45 degrees. Same is for this. It also has an angle h and angle 45 degrees. That makes them similar. But the fact that this side and this are congruent tells that the two triangles are congruent triangles. So the other corresponding sides are equal. Since this is 4x, this must be 4x. And since this is 8 meters, this must also be 8 meters. Come here, draw a line that will connect this point and this. Look at this triangle. It has a side of length 4x and that of 1 over 2yz. The angle between them is 45 degrees. Same is for this triangle. It has sides of length 4x and 1 over 2yz. This angle between them is h plus s, which we have here to be 45 degrees. That makes the two triangles congruent triangles. So since this is 1 over 2xc, this must also be 1 over 2xc. Come here, this angle 45 degrees plus 45 degrees is a right angle. We look at this triangle. It is a right angle triangle. Using the Pythagorean theorem, this is the hypotenuse. So 1 over 2xc all squared equal to 8 squared plus y squared. 8 squared is 64. We take the square root of both sides. Here, square root of 1 over 2xc all squared is 1 over 2xc. So 1 over 2xc equal to square root of 64 plus y squared. Back to this equation. Replace this 1 over 2xc with square root of 64 plus y squared. Take this 8 and this y to the left. Square both sides of the equation. Here, square root cancels square. While here, if you expand it, it is 32y squared plus y squared plus 64 minus 8 root 2y squared minus 64 root 2y plus 16y. This y squared eliminates this y squared, and this 64 eliminates this 64. Bring these to the right. 8 root 2y squared minus 32y squared, we can factor out y squared. Here too, we can factor out y. This y squared divided by this is y. Divide both sides of the equation by 8 root 2 minus 32. We'll get y equal to 16 minus 64 root 2 all over 8 root 2 minus 32. If we multiply it by 8 root 2 plus 32 all over 8 root 2 plus 32 and simplify, it is y equal to 15 root 2 plus 4 all over 7. Come back to this equation. Substitute the value of y. X squared equal to 2 plus 15 root 2 plus 4 all over 7 minus root 2 all squared. Here, simplifying into a single fraction, it is 15 root 2 plus 4 minus 7 root 2 all over 7. 15 root 2 minus 7 root 2 is 8 root 2. Expand this bracket. it is 128 plus 64 root 2 plus 16 all over 49. We can put this into the fraction by multiplying it by 49. 2 times 49 is 98. 98 plus 128 plus 16 is 242. So it is 242 plus 64 root 2 all over 49. Take the square root of both sides of the equation. Here, square root of x squared is x, while here, square root of 242 plus 64 root 2 all over 49 is square root of 242 plus 64 root 2 all over 7. Come back to this equation. 1 over 2xc equal to square root of 64 plus y squared. Substitute the values of x and y. Then simplify. We'll obtain z equal to 2. Now back to this triangle. We see this cycle is inscribed in it. Whenever we have a cycle inscribed in a triangle, the radius of that cycle equals the area of a triangle divided by the semi-perimeter. So we can say R equal to area of triangle CDE over 1 over 2 into z plus 1 over 2xc plus 1 over 2yz. This z can be written as 1 over 2z times 2. From here, we can factor out 1 over 2z. So R equal to area of triangle CDE over 1 over 2 times 1 over 2z into bracket 2 plus x plus y. Back to this triangle CDE. To calculate its area, we can use the formula 1 over 2ab sine c. Taking this as a and this b, this must be c. We substitute it here. So area of triangle CDE equal to 1 over 2 times z times 1 over 2yz times sine 45 degrees. Substitute it here. This z eliminate this z, and this 1 over 2 eliminate this 1 over 2. This also cancels this. Sine 45 degrees is 1 over 2 root 2. We have the value of x, y, and z here. Substitute them. So R equal to 1 over 2 times 15 root 2 plus 4 over 7 times 2 into root 17 minus 4 root 2 times root 2 all over 2 plus square root of 242 plus 64 root 2 all over 7 plus 15 root 2 plus 4 all over 7. These can be simplified into a single fraction. So it is 14 plus square root of 242 plus 64 root 2 plus 15 root 2 plus 4 all over 7. This 7 eliminate this 7. This 14 plus this 4 is 18. This 1 over 2 times this 2 is 1. This multiplied by this is 30 root 2 plus 4 root 2. So R equal to 30 plus 4 root 2 multiplied by square root of 17 minus 4 root 2 all over square root of 242 plus 64 root 2 plus 15 root 2 plus 18. Back to this equation. Substitute the value of R. If you use your calculator, we'll get an approximate value of 27.4678. So area of two congruent cycle equal to 27.4678 square meters. Thank you for watching. Please like, share and subscribe, and also turn on notifications. Thank you.